Can you see the whiteboard now?
Yes, sir.
Okay.
Sir.
So now we are going. This time I'm going to teach you this CV313 course, which is basically indeterminate structure analysis. Before moving on to course content or reference material, let's just discuss briefly. If I give you this beam, let's say there is a force of 10 kilonewton, this is 5 meter, this is 5 meter. What will be these reactions? Can anyone tell me these reactions?
Sir, 5 kilonewtons and 5 kilonewtons.
5 and 5. Let's suppose there is another beam. And there is a force of again 10 kilonewton. This is 5 meters, this is 5 meters. What are these reactions? Anyone?
Sir,
Yes.
5
sir, 5 और 5 होंगे vertical.
And this one. Think about it. You have 1 minute. Anyone?
Zero होगा.
Movement is 0. Anyone else?
Sir, zero ही होगा. आपका moment.
And
सर ये इनडिटर्मिनेट है, ये इस तरह मेरा नहीं ख्याल कि हो सकता है.
indeterminate. Any other opinion?
सर 50 नहीं होगा.
50. अरुण आप क्या कहते हो?
Sir, indeterminate है ये. Sir, तो नहीं होगा.
Okay. Yes, this is an indeterminate structure, and we can't find out these reactions just like by using we can do that, but when we apply, let's apply this, the simple equilibrium equations. We have sigma fx is equal to 0. There is no force in the x direction. Let's take sigma fy is equal to 0. That will give us Ra plus Rp is equal to 10. Then we can take moment at A is equal to 0. That will give us, let's say this is A and this is B. Then we have Rb into 10 minus 10 into 5, and this one will be Ma plus, let's call it that, plus is equal to 0. Then we can, what else? We have these three equations, right, of equilibrium. So from these, if we see, we have two equations and we have three unknowns. And no matter what we do, we can't find or we can't figure out these three unknowns by using these two equations. So this is basically an indeterminate structure, and we do need to have another equation or some method using which we can by the application of which we can solve this question. And this is what this course is about, that is indeterminate structural analysis. In the previous course, we studied these determinate beams, determinate frames and trusses, and we calculated these forces. In this whole course, we will be studying different methods for the analysis of indeterminate beams, trusses, frames, arches, just like in the previous course. Those all of them were the determinate structures, and this time we will have indeterminate structure. Even we will be plotting the influence line diagrams for the indeterminate structures. There are different methods. Obviously, you can imagine that these problems or these structures would be complex compared to the determinate ones. But I can assure you that once you start taking interest in it, it will be fun to do. It won't be that much complicated, but you can say that these questions will be lengthy. But once you start taking interest, you will find them pretty easy. But obviously, you need to put in your full attention to get the right answer, because the procedures are long and you can make mistakes. So you need to have, or you need to solve the questions very carefully. So before we move on to the actual topic, let's just briefly review the what is determinacy or indeterminacy. Can anyone tell me that how many types of determinacy we have studied in previous course? How many types of determinacy are there?
So two types,
What are those?
determinate and indeterminate.
For example, let's say how many types of determinacy are there? Determinate and indeterminate are type of structures.
Internal and
External, internal.
External and internal, right? The external one depends on the based on the external reactions, and these internal one are based on the arrangement of members and joints. If you remember, we also studied one or two formulas for the for external one. It's simple. You just figure out that how many unknown reactions are there, and you compare it with number of equilibrium equations, which are 3, and you can easily figure out that if whether the structure is externally determinate and indeterminate. For the internal indeterminacy, you have different formulas for that. For example, for the case of truss, we studied this one. B plus R is equal to 2J, or I can write it as M plus R is equal to 2J. M is the members of the truss, R is number of reactions, and J is number of nodes or joints, right? So by using this formula, we can figure out the internal determinacy of the trusses, right? And similarly for the frames, can anyone tell me what formula did we study for the frames?
R is equal to 3N.
R is equal to 3N. Okay, this is the one that we already studied for to figure out the internal determinacy of the frames. I'm giving you another formula, that is 3M plus R is equal to 3J. Now I leave it up to you to figure out that what is the difference between these two formula. If you can figure out right now, you can tell me. If not, just think about it later, and just let me know in the next class that what is the difference between these two formulas. And okay, next time I will tell you what is the difference. And in this formula, M is the number of members, R is again the reactions, and J is the number of joint. And by using this formula, you can figure out what is the internal determinacy of frames. And this one is for truss. So let me give you some simple examples. So can you tell me that whether this truss is determinate or not? You can solve it on your notes.
सर ये राइट पे फिक्स सपोर्ट है
This is a roller and this is a hinge. So what is the external determinacy? Is it determinate or not?
Determinate.
What?
The first one, 19 is
Mhm.
equal, 22 is equal to 20. So is it determinant?
Internally determinate or not?
Internally determinate.
And externally?
Externally.
Sir, indeterminate.
Internally or externally?
Externally.
डिटर्मिनेंट है दोनों
It is determinate because this is a roller and this is a hinge. So we have three reactions and we have three equations of motion. So externally it is determinate and internally as well it is determinate. What about this frame?
सर इसमें सेक्शन बनाएंगे जो क्लोज लूप है उसमें
Give me the answers. How many members we have in this frame?
सर सेक्शन करे तो फिर 3 मेंबर्स हैं
Sir, 8 members
Okay,
The
let's say
three
8 members. Without sectioning, there are 8 members, right? 1, 2, 3, 4, 5, 6, 7, 8. 8 members. How many joints? 1, 2, 3, 4, 5, 6, 7, 8. Joints is 8. And how many reactions?
फिर आप
Nine.
supports को joints क्यों मान
9
रहे
है
हैं?
सर
Because the member is connected to the support. No?
Sir, reactions 9 कैसे हैं और 8 तो समझ आ गई लेकिन एक और कहाँ से आ रहा है
3 reactions on each support. And in this question also, if you remember, we take this support as a joint. So we have to take the member and joint. And this is the difference between that formula that R is equal to 3N and 3M plus R is equal to 3J. Now in this formula, if you want to apply this formula, then you have to do that method of sectioning and you have to take the section and you have to take the reactions at each particular internal forces at each section, and then you will apply this one and get the internal indeterminacy. But in this formula there is this factor of 3m. Now if you want to apply this formula, you don't have to do the section. It's just like the formula for the truss. You just count the members, you just count the number of joints and reactions, and you will get the internal indeterminacy of the frame directly. So for example, for this frame, will it be determinate or indeterminate? 3 into 8, 24 plus R9 is equal to 3 into 8. So 33 is equal to 24. So it is indeterminate internally by 9 degrees, right? And what about externally? Is it determinate? I think no. Externally it is indeterminate by 6 degrees. So any confusion about this one?
सर ये आप जॉइंट्स पे जोन से स्पोर्ट्स और जॉइंट्स ये किस तरह हमने पॉइंट लिया इस पे जॉइंट्स
किस पे?
ये स्पोर्ट्स पे आपने जॉइंट्स काउंट किया ना ये 3 ये इसकी समझ नहीं आई
अच्छा ये ट्रस्ट के केस में आप इसको ज्वाइंट लेते हो?
यस
You
सर
do?
यस सर
So why not here? Why are you confused about this? Because we have to take the number of joint, मतलब member जिन जहाँ से connected है वो एक joint है, तो member यहाँ पे भी connected है, this is a joint, यहाँ पे भी connected है, this is a joint. अगर आप उससे confused हो कि इस formula में शायद हम नहीं लेते थे I guess, तो you can use this one directly, but I have given you this formula which is equivalent to the one that we use for the trusses, so we have to use the same methodology. Okay.
जी सर यस
सर
Yes.
सर एक्सटर्नली 6 डिग्री कैसे होगा ये समझ नहीं आया
How many reactions we have?
9
9 reactions. How many equations of motion we have? Equation of equilibrium we have.
सर 2 3
कौन सी? Sigma fx is equal to 0. Sigma fy is equal to 0. And sigma moment is equal to 0. So we have 3 equations of equilibrium and we have 9 reactions. So 9 minus 6 is equal to 3. I'm sorry, 9 minus 3 is equal to 6. Right?
यस सर
So that is why it is 6 degree indeterminate. What about this frame?
सर which one
How many members we have in this one?
7.
7
3, 4, 5, 6, 7. 7 members. How many reactions? 3. And
10.
how many joint? Sorry. How many reactions?
9 reactions
9. Yeah. And how many joints? 1, 2,
4
3, 4, 5, 6, 7, 8. Right? So is it a
सर
determinate?
सपोर्ट वाली को जॉइंट कंसीडर करते हैं
Joint क्या होता है?
सर जो फिर फिक्स होता है मतलब
हैं?
यहाँ पर कुछ चीज कनेक्टेड
Joint जहाँ पे member connect होता है.
जैसे
ठीक है. अब member ये member जो है, for example this is member 1. ये कहाँ पे connect हुआ हुआ है? यहाँ पे connect हुआ हुआ है. यहाँ पे भी connect हुआ हुआ है.
यस सर
ठीक है. तो ये भी एक जॉइंट है, ये भी एक जॉइंट है. इस पॉइंट पे भी फोर्सेस हैं, इस पॉइंट पे भी फोर्सेस होंगे. सिमिलरली ये अगर मेंबर 2 है तो ये यहाँ पे भी कनेक्ट हुआ हुआ है और इधर भी कनेक्ट हुआ हुआ है. ठीक है. तो ये भी इसका एक जॉइंट है और ये भी इसका एक जॉइंट है. इधर से भी इसको फोर्सेस ट्रांसफर होंगी, यहाँ से भी इस मेंबर पे फोर्सेस ट्रांसफर होंगी. ठीक है. तो जहाँ से भी फोर्सेस ट्रांसफर हो सकती हैं वो एक जॉइंट है.
यस सर
So is it determinate or indeterminate? Let's just apply this one again. We have 3m plus r is equal to 3j. You can also do it by method of section and you will get the same degree of determinacy or indeterminacy. if you are
Indeterminate.
comfortable. So 21 plus 9 is equal to 24. 30 is equal to 24. So 6 degree indeterminate, right? So this is also internally an indeterminate structure and externally also indeterminate structure. So for these type of structures, we have to apply different methods to fix
joints
8, 1, 2, 3, 4, 5, 6, 7, 8. Yes, 8 joints. I have written 8, right? 9 reactions. So is there any confusion? Okay. And for this beam, obviously you can see that this is an indeterminate beam. We have 1, 2, 3 reaction, 3 and 6 reactions and 3 equations. So this is also 3 degree indeterminate. So this was a brief review of these some of these formulations that we have already studied to figure out the determinacy and indeterminacy of the structures. So the different methods that we are going to study in this one is this force method or the slope deflection method, moment distribution, and we will also study the analysis of indeterminate arches, this three moment equation, and the influence line also we will be studying for indeterminate beam. And this is the last method for again for the analysis of these beams and frame structure. We will apply all these method on frames, beams, and trusses. So this time the course is much more than the previous course, but again we can do it if we are on.
Sir, difficulty level बता
Difficulty level is obviously a bit higher because it says 300 level course, so difficulty level is a bit higher. What?
सर ये जिस तरह के अब इनडिटरमिनेट फॉर्म्स अब हम पढ़ेंगे और मेथडोलॉजीज ये पुराने उन पे तो बेस कर रहे हैं, लेकिन आप बता रहे हैं मजीद डिफिकल्ट हो जाएगा, तो उसके लिए तो फिर ये जिनकी पिछला कोर्स वीक उनसे ये हो जाएगा सर?
पिछला कोर्स वीक हो जाएगा? I think yes, because जो पहले वाला कोर्स है उससे कुछ डिफ्लेक्शन का मेथड हमें चाहिए जो कि हमें इसमें भी यूज़ करना पड़ेगा. फॉर एग्जांपल कॉन्जुगेट बीम और मोमेंट एरिया मेथड जो हमने पढ़े थे, लेकिन बहुत ज़्यादा लिंक भी नहीं है पिछले कोर्स से, एंड तो आई डोंट थिंक सो वो इतना मैटर करता है. सो अगर आप ये कोर्स ठीक तरह से पढ़ लोगे तो ये कोर्स आपका अच्छा हो जाएगा. एक आध मेथड शायद हमें पिछले कोर्स का यूज़ करना पड़ेगा यहाँ पे, बट वो भी लेट्स से 5% यूज़ होगा, तो बाकी सब कुछ नहीं आई है. सो इस कोर्स में अपनी लगा सकते हैं. बाकी shear force bending moment डायग्राम आपको आनी चाहिए, उसके बगैर कुछ नहीं होगा. So these are some reference material. Obviously the important thing is class lectures, because if you remember हम different problems कर रहे होते हैं different books से और different methods apply कर रहे होते हैं. So it's better that you make your own notes ताकि वो sign conventions और इस तरह के issues, क्योंकि हर book की sign conventions and everything is different, so you might get confused. So it's better, I suggest you to make your own notes. And then if you want to consult some books, there is this Indeterminate Structures by C.K. Wang and by Sayyid Ali Rizwan. I think this person was professor at UET Lahore and NUST also, and currently this person is serving at FAST, I guess, in Lahore. Yeah. So this book, he wrote this book of Indeterminate Structure, and it's quite good. So if you want, you can buy this one. We studied from this book because at that time this book wasn't available. So now most of the universities are following this book from Sayyid Ali Rizwan. He's a good professor in structures, very good professor in fact. And then there is this Hibbler book, the same book that we were using in basic structure analysis. But in this book, there are only two topics. I think the force method and the other one was slope deflection method. So most of the topics or all of the topics are in these first two books, and one or two methods are in this Hibbler book as well. So we will be following these three books.
सर ज़्यादा recommend first two में से किसको करेंगे?
First two, I think this book is available somewhere online. So this book you have to buy. So if you want to buy, you can buy this one, and this one you can find it online somewhere. Or I think in HEC
Right.
library this book is also available, so you can get the online version. So just keep both books with you.
Right.
So moving on to the lecture, let's just study what are the structural differences between the two type of structures: statically determinate structure and indeterminate structure. I will be using this abbreviation SIS more frequently